Hello everyone. Today we are starting a new topic which is IPv6 Basics to Advanced, and in this video series what we will be learning is IPv6 from a design and deployment standpoints mainly. But I will cover some of the basic know-how features of IPv6 as well. But our key focus in this series will be around design and deployment. Very recently, I have got some opportunities to work on some of the largest IPv6 deployments, and that is what I will be sharing with you. Basically, the key learnings that I have had, we will cover that in this lecture series. As you all know, IPv6 has have a very long history. In fact, IPv6 will be celebrating its 30th anniversary very soon. The first RFC that came in for IPv6 was in 1995, and the first Cisco iOS that had supported IPv6 was released in 1998. Yet, there are many organizations which are ignoring it. In fact, some of the technologies which had came much after IPv6 had seen a wider deployment. You may take the example of VXLAN is one of them. Up to some extent, MPLS is also one of them. But somehow IPv6 had not picked up that pace until recently. So in this series, what we will be covering is what are those key drivers behind IPv6 that we are talking about it now, or the organizations that are talking about IPv6 now. You can relate it to a very simple analogy as well. Like some of you may be an avid car lover, and even the automobile companies, they make very great cars which run on petrol or diesel, but that cannot be your future. This has to change, and something green or a sustainable, for example, an electric car, has to adopt a wider market share. Right? So, with that thought process, what we will be looking at, so it's as I was saying, these will be some lead series of sessions. So, what is the objective behind this? And as usual, we will start with the why part. Why, in the first place, you need to learn IPv6? That's what we have done with our earlier series as well. For example, segment routing v6 or EVPN as well, where we have recorded close to 8 to 9 hours of a video series. But now we will do the same with IPv6 also. Then we will be looking at some of the IPv6 know-how. How does this protocol work basically? But the key topic or the key part that we will be focusing more is this design and deployment guidelines. So I will keep this series very basic so that even the beginners can relate to it, but even the experienced users will also find it useful. With that, my name is Sunil Pareek, and let's get into the agenda that what we will be looking. So today's session, because it is very first session, I am keeping it light. So we will look at, of course, why IPv6 and why now. And you may wonder that now IPv6 was developed to address the shortfall of IPv4 that we are seeing for quite some time. But that is a well-known fact. I will not be talking about much. You pretty much, whenever you see these IPv6 discussions, it starts with that, okay, we are running out of IPv4 addresses. The internet registries don't have any block left. But we will look at some other factors also. And there is one more factor that played a key role, is that there is a strong push from the government side as well across the globe to move to IPv6. But what I will be talking about today is some of the architectural changes that I had seen or industry had seen where IPv6 is playing the bridging point. So that is what we will be looking at. And during these engagements, during these discussions with different customers across the globe, I came to know about some interesting facts as well, and few of them I will be covering in this session as well. So if you are planning to stay till end, we will talk about some interesting facts as well. So first, let's just start with architecture standpoint, right? Let's just start from the architecture. So whenever you deploy a network for an IT company, let's say this is a IT company, this is just a room, but assume that this is a big enterprise IT campus, and I got the opportunity to do many of these network deployments. And in most cases, this is something that is very clearly documented. Vendors have a validated design, and when you sit with the customer, you already have this standard design in the back of your mind, and there are high chances that that will fit their requirements, like standard access, aggregation, core, or a leaf spine type of design. And if we talk about the endpoints, more or less the similar number of or similar type of endpoints are connected to the network. But suddenly, let's say, and this has happened actually with me, that you get a network from a big stadium and you need to deploy a network here, or you get a project where a manufacturing company which is spread across miles and you need to deploy a network for that. You can't go with this mindset to deploy this network or this network. Obviously, there are some different, or in fact, completely different requirements that are here and here, right? So that was one key shift that I had seen in these recent years. And believe me, working with these networks was a completely different experience altogether that we will be covering. So, the first thing is the unified connectivity for the heterogeneous devices. One thing that I had seen, that the devices are getting connected over a Wi-Fi network, the devices are getting connected over a private 5G or a LTE based network. And in fact, private 5G is one which is getting a lot of tractions from the enterprises these days. And on a side note, there is a like few sessions I have recorded on private 5G as well. Very basics for the beginners that if interested you may watch. Then there can be some endpoints which are connected over Wi-Fi or Bluetooth. But I had seen from the customers that there are use cases where a endpoint, irrespective of its connectivity type, need to talk to each other. Right? And that's where the IPv6 is playing the bridging point. And I have not covered all here, like there can be a wired host as well or endpoint as well, or there can be connected endpoints on RFID as well. But all of them talk this common language for the transport, which is IPv6. But then you may argue with me here that why you are talking about IPv6 here. They can very well talk on IPv4 as well. Well, you are right, but let's look at this picture, and it had changed drastically. I had seen multiple versions of this picture where if you look at this blue line, which is like the number of devices per person, had only gone up, whereas the world's population graph stays straight, but the number of devices that per person have increased manifold. In fact, here in my setup currently that I have, I can see that there are 4 devices which are connected to the network. And IPv6 was designed to have this level of scale in mind, right? That is where we are talking about IPv6. Another trend that I want to share with you is in the enterprises. Earlier, it was like laptops or VoIP phones that used to connect with the network. But now, with these advancement of the smart buildings, what we see is that there are more and more type of devices. In fact, I was talking to a customer and they had like many thousands, like close to 6,000 of CCTV cameras that they wanted to deploy in to cover their whole premises, and it was all over IP. Then this building automation and control network also speaks the language of IP. In the smart buildings, there are so many sensors that are deployed, and all these sensors are IP based. The building's power, the lighting systems, right, that is also connected on the network, or the HVAC system in a enterprise building is also connected over enterprise network. I would let that sink in for a minute. So if you see here, if we talk about Cisco Catalyst switch, right? These different type of endpoints are connected to this network now, right? All of them use the language of IP. They use the transport protocol as IP, which is IPv6 in this case, and they are connected to the network, right? This had like this change that I had seen was one of the key factors which like the customers are looking at IPv6. Even there was a healthcare customer that I was talking, and they were actually looking at something sort of smart hospitals where even their systems connected in ICU are connected to the network. Doctors are digitally downloading the patient records. So it is not only the number of endpoints that had gone up, it is also the type of endpoints that has gone up. And when we are talking about enterprises, as I was saying earlier, there are these different type of connectivities: wireless, private 5G, wired Ethernet, Bluetooth, right? That I was showing earlier. To give you one more example, I was talking to a customer, and it was an enterprise customer. So I went with that standard core aggregation access switch design in my mind, and that's where one of their architects said that they want to connect their parking facility also to the enterprise network. And when he showed me the parking, it was like multi-story parking, and it was like really big, spread across a wider, I think a mile or so, because it was a very big campus, and there were other adjacent towers as well for the same company. So that is where like you use these different type of connectivity, right? And to address the requirement of these two, the number of endpoint, the type of endpoint, you use this. Let's look at this with another example as well to make this point more firm, that now there are these power over Ethernet or UPOE powered buildings as well, where a Cisco switch, if I talk about, provide 90 watts of power on a particular port. That is enough to power, let's say, if a light is connected to it, right? A LED light, that is what, if you see, this was actually one deployment that we had taken care of. There was a sensor, and this light is actually connected to a network switch in the backend. So you see how this endpoint ecosystem is evolving and demand a more or a bigger and simple, manageable IPs, right? It IPv6 have a lot more flexibilities, easier management, but we will look at that in the subsequent sections. But for now, you only like try to consume this point that even the building lights are also connected to the network, right? And the IP addresses to these can be allocated via DHCP. This is just a sample configuration that I thought of putting down. We will not talk about any config snippets, but just to show you that this is a actual scenario that has been implemented and working fine. Here, one of the interesting fact, in fact, one of the customer asked this point that Sunil bhai, if we upgrade the switch where all these lights are connected, let's say there is a floor and they are connecting like multiple lights on that floor to this switch, and if they upgrade the switch, what will happen to the building lights? Will there be a wipeout, or will there be like everything will be dark? So that is where the concept of perpetual PoE comes into picture, which even like if you upgrade the switches, uh, the lights and all will not be impacted. But that is not the topic for today. So here you see in this the last slide, basically all these endpoints that are connected, right? Most of these endpoints, and listen to me very carefully here, most of these endpoints are related to the building infrastructure, related to the safety or the functioning of the building, not necessarily directly connected to the employees' productivity. Whatever applications they are using on their laptop to perform their day to day job is different. We have not listed that here. So, the point that I'm trying to make here is that all these things contribute to employee experience. So, now your network that you are deploying, right, all these different type of endpoints is also contributing to the employees experience as well as their productivity, right? So now experience and productivity, right? Both, right? So that is where this becomes more important, right? To have a robust transport ecosystem that support that smart building, and that is what see are more inclined towards IPv6. And I will cover some more factors like the simpler management that I was saying, security that we will look at in the subsequent lectures. Another thing that I found on the web, that Facebook has actually decided to move and migrate to IPv6 several years ago. And I was reading an article on the internet. I will put that link into the descriptions, where they are claiming that the network had become faster when they connect over IPv6. This is actually on top of the easier management and end-to-end connectivity without any net, right? We will look at how this end-to-end connectivity also helping the customer in their AI slash ML ops, right? That we will talk in the later videos. But point here on this slide is that IPv6 networks are faster as claimed by Facebook, and not only Facebook. In fact, Apple announced some time back that the device's connection setup time is 1.4x faster when IPv6 is in use. Or there was a customer from Akamai who did a case study in 2019, which showed that the throughput have increased by 38% on average when they compare to IPv4. All these articles are available over the internet. I can put the link into the descriptions if some of you want to go and read about it. But the point is not only scalability, not only security, not only easier management, there are some more reasons to consider IPv6 now. And apart from, of course, IPv4 running out or the government push that I said during the start of this video. And yeah, this is the reference from where I have taken this facts. I will put this link. So there was this IPv6 day where somewhere around 2011 or 12, where suddenly like the internet decided that let's go on IPv6, and they asked different companies, service providers to have IPv6, right? But then the problem was that even after like 2011 or 12, even few years later, whenever a host on IPv6 connect, I had seen it, we have tested in the lab, either the connection used to time out or the connection like sometime is not working seamlessly. So that is where this happy eyeball RFC came, where one of the approach for IPv6 was to have a dual stack. So basically you have both IPv4 and IPv6, and this RFC allows, or basically algorithm which attempt the connections on V4 and V6 both, and it choose whatever is the better one to actually enhance the customer experience. So with the dual stack approach, and we will talk about this dual stack as well in our series. What is good with it, what is bad with it, we will look at that. But this RFC had actually contributed in enhancing the customer experience when we have both on the network. Right. So with that, another interesting fact, in fact, one of the customer asked me like, how big is the IP address space? How many IPs we have? Like if you look at VXLAN, there are like 16 million VNIs that we talk about, right? IPv4, it's a 32-bit space. IPv6, it's actually 128 bits. Right? So my math skill doesn't allow me to read a number that is that big. If you can read it, it is good. Otherwise, don't worry. Let's just understand this number from a network engineer perspective. So let's understand this better. So let's say that you are a network admin and I give you this task, deploy one LAN network, only one LAN network with a 64-bit IPv6 space. So your first 64-bit are your network address, and then the last 64-bit are your host. Right? So you need to allocate this to a LAN, right? So if we, let's say, go with IPv4/24, you can have somewhere around, let's say, 255 IPs there. With IPv6, you can have, again, my math skills doesn't allow me to read even that big number, but you will have this many IPv6 addresses in slash 64, right? But let's dig deeper and understand this number better, right? So let's take a general example where you are a network admin and you are allocating 1 million or 10 lakhs, if I need to put it in the Indian context, IP addresses per second. It may not be realistic, but let's say a very, very, very big organization, you are working as a network admin, you are allocating 1 million or 10 lakh IP addresses per second. In a year, we have 365 days. And if you do the math, it will come somewhere around 3 crore 15 lakh 36,000 seconds or 31,536,000 seconds in a year. So 1 second, I am giving 1 million IP addresses. So how many IP addresses I will give in a year will be equivalent to this. It is a simple math, right? I simply multiplied both the numbers and this comes. Right? But I have this many addresses. So these are the number of addresses I give in 1 year, right? I have these many. So let's just divide these two numbers. Like this is per year and this is the total addresses. So I will need 58,494 years to consume this whole address space. That is the size of IPv6 that we are talking about. And probably like by then, or if there is something like this goes where you have a requirement like this, there are very, very high chances that within 50 years or so, there may be a new protocol, a new way of working that comes. In fact, there are some discussions around named base address forwarding or something. Those are happening, but let's not go in that direction. But you got the point here, right? That even with the 64/64, right, you have a huge address space. So if some customer says that like why to waste IP addresses, even if you go with 64, you have a plenty of leeway to go with, right? And with that, like by now, I hope you got some context around why we need to consider IPv6. And if you make a plan to move towards IPv6, or if you are working with a customer who need IPv6, right? The network or the security piece, which are here at center that you see, are not the only one. There is a whole ecosystem that you see here need to be migrated. The business applications, the enterprise applications, the monitoring, how you are monitoring your network, all these pieces need to be migrated towards IPv6. Now you may be responsible only for the network part, but it is good to have this overall picture when you are discussing IPv6 with your customer or in your network. So with that, as I was saying, IPv6 is approaching 30. So it's time to get it on board. And I will cover my experience in this. But as I said, let's keep this first session very light. So we come to an end of it. So if you have learned something new, if you have liked some of the facts that I have talked about, feel free to share it with your friends. And with that, I would like to say thanks a lot for the time that you had spent with me. I hope it was a valuable use of your time. Thank you.